These rules only work if it's 1 plus on the bottom. Okay, I'm sorry, if it's 1 plus or minus on the bottom.
Oh, wow. What else would it be?
I'll show you. Okay, here's an example. I don't even know what this is. I can't wait to find out. R equals 12 over 3 minus 6 cosine theta.
Well,
Okay.
exactly. So
I know it's horizontal. I know it is horizontal. Okay? That's all I know so far. I see it's minus, so it's probably going to be counterintuitive. So it's okay. Well, that's what I'm going to do. This rule only works if there's a 1 here, so I'm going to rewrite it as 12 over 3 times 1 minus 2 cosine theta. With me so far? Okay, now, here I can reduce. That won't always be the case. Well, you're always going to have to, actually, so it'll probably be the case here. So this is going to become 4 over 1 minus 2 cosine theta. Okay? Now I know something about this. Once I get a 1 here, this coefficient is my eccentricity. So
that's
my
what the E stands for.
Yep, so my eccentricity is 2. Eccentricity greater than 1 means what shape is this?
No.
Hyperbola.
Hyperbola. Won't help you on this test. Don't worry about it. Okay, now, if this top has to be E times P, what does P have to be? 2. And this is my distance from my directrix to my focus. Okay, so right now, I know I'm looking at a hyperbola.
What if they don't match up? Does that change the conic, or just is it wrong?
They have to match up,
Okay.
because
I didn't know whether they had to.
you may have to get really creative. Like if I had a 1/2 on top, I'd have to realize that my P must be 1/4, 2 times that. You know what I mean? It can get ugly, but this always has to work.
Alright.
Or this is not a
Wait.
conic.
So seriously,
It's not. If it doesn't work, it's not a conic. It's just some other really annoying polar equation.
what else would it be if it's not plus or minus?
Yeah, I mean it pretty much has to work if it's in this form.
Well,
But if I
yeah,
put like a
you said
tangent in
earlier
there.
this only applies to plus or minus. Like, thanks. We're not going to be using anything else, or
no, we're not going to be. It'll always be in this form for this. If it's in this form, if it's in one of these 2 forms, it's a conic and you can make it work. You might have some really ugly numbers. Okay, we know it's a hyperbola. We know one of the foci is at the origin.
Why do we know that E is 2?
Because
Once this is equal to 1, then this coefficient is the eccentricity.
Okay, then how do we know P is 2?
Because this top is EP, and if we know E is 2, what times 2 is 4?
Okay.
It's like magic.
I really didn't think this thing.
Okay, I know, you've been catching up. Okay, so I've got a focus here. Because it's minus, which way is my second wing, to the right or to the left?
Right.
Left. -2 too, right?
Yeah.
The other one is right.
Can I just number it? Is what my question is.
Yes.
It goes in. Like the hokey pokey.
It goes over here. The other wing is further to the left. Okay? How far over to the left? Well, let's see.
It's minus.
Hang on. My directrix, the distance from my focus to my directrix is 2.
Sorry.
Okay? And the directrix,
Whatever this is.
my arm is.
Oh, it's kind of
So this is 1.
Right.
1 plus 2.
now,
Always 2.
Wait, no, you're not touching me with that.
I mean, it's always going to
Okay.
go, so there.
it's going to be one of these wings. Hang on. Now, this next part's important. Okay. Okay. One of these wings is going to wrap around the pole. The other wing is going to go out like this.
It's going to be twice.
Now, not necessarily. This P just tells me where the directrix
How
is.
do we know how to graph it just with
Well,
like
no,
those points?
I'm glad you asked. Okay, now,
I was going with the end.
Yeah, I should
Okay.
have asked.
here's what we're going to do next. To find the vertices, since it's cosine and horizontal, we want to know everywhere it hits the x-axis. Okay? The places it hits the x-axis are in polar form when theta equals 0 degrees and theta equals pi degrees, 180. Okay? So we're going to plug those in. To our simplified one, r equals 4 over 1 minus 2 cosine 0, and r equals 4 over 1 minus 2 cosine pi. One of these should get a, since both our vertices are over here, one of these should get a negative answer. In fact, if we don't get a negative answer here, we know we've done something wrong. We know we need a vertex over here, which means we need to have a negative radius. To have a negative radius, we must wind up with a negative answer here.
I know.
Perhaps that's the other way around.
Wait, no, because it would be, because the cosine,
Well, what's a cosine
of
of
0 is going to be,
One.
1. Never mind.
And what's
I was
one?
thinking it would be negative 1.
Right, and
That's
then,
the other one.
yep, 1 minus 2, so that's going to be 2 times 1, so this is going to be 4 over negative 1, so that's negative 4.
And then
What are we going to get over here?
1 plus 2.
negative
2 times negative, cosine of pi is negative 1,
I
right?
just said that.
3 4 third.
Yeah, so we're going to get 4/3 for other vertex.
That's not right.
So it hits it 1 and 1/3, 2, 3, 4. Okay, getting the curve of these is really hard. There's no box to draw. One way to get the curve of these...
Where? Okay.
By the way, you totally ignored what I said.
I'm sorry, did you say something?
I'm pretty sure you messed that up
Wait,
pretty bad.
what?
Where?
Oh.
Where?
4/3 is positive first. I'm pretty sure. I believe that's on the negative.
That's a good point. That's a very good point.
Dun dun dun.
Dun dun dun.
Indeed.
You know what? I don't like this math. Can we go back
I
to
love
like
it.
I question though. D is 2
No.
because
It's always the coefficient in front of
Why
the
is this
cosine.
on the
Because-
left side?
Huh?
If it's a minus, there's a minus, and
Right.
why isn't it further right?
and
Hold on, here's what I'm going to make a table for this one, which I should have done to begin with.
There's something
and
off.
P is
I'm going to find my 4 points.
I'm gonna get a wet paper towel.
That was
Okay.
Barbie just wants to stick my head
0.
in your...
We got negative 4, correct?
What?
Guys, stay with me on this. 0, we got negative 4, right?
Sure.
Okay, what's the cosine of pi over 2?
Oh, 0.
0. So that's going to be 4 over 1, which is going to be positive 4. Right?
Yeah?
Okay, and pi, what do we say we got? We got 4/3?
Yeah.
And that's the one we think is wrong. Or at least at 3 pi over 2, we should also get 4, right?
Uh-huh.
Like the cosine of 1 is, the cosine of 90 is negative 1.
Yeah. No, cosine of 90 is 1.
So then why is there a negative 1?
That's 180.
Oh,
This is 180. Okay.
Bro.
180, it's negative 1. And if we put it into the other one, we won't get anything different. We'll get 12 over 3 minus... Get 12 ninths, which is the same thing. So yeah, this should be... That's a problem if I'm getting a point here and out here, and the pole is supposed to be one of the foci. Let me double check an example
Maybe
here.
E isn't supposed to be, or P are supposed to be the directors.
I don't get it.
Hold that thought.
How do you find the directors?
Yeah, how do we find... Oh, it's 2, isn't it?
Yeah.
But how do we know that it's 2?
Because P is the distance from the directrix to the focus.
Oh, got it.
Now, there's a similar example here.
If it's minus, why is the second focus further left? I don't get that.
Oh, duh! Stephen! Stephen!
What?
Stephen!
Use your words.
like a big boy.
Pi, positive 4/3 in the 180 degrees direction. Remember how polar coordinates work?
No.
Okay,
The
that-
teacher's very well.
obviously I didn't, okay?
Funny because
Stephen threw me for a loop.
Then what did
It should be positive 4. Okay, now this negative 4, and I did it right on one of them, and then you threw me off on this one. 0 degrees negative 4 means look this way, but then negative means turn around.
So then it's
Pi.
but this
Oh, yeah.
Means go positive units in the 180 degrees direction, so this is the point.
Wait, no, I don't get that because that was what I really didn't understand. If it's you have to go to the negative and then turn around and then
Okay,
look back.
well then let me...
That's the exact same spot that you're supposed to be at.
Nope.
Yes,
Oh,
it is.
Sweetie? Alright, hang on.
You
In
did
polar-
not explain this to me.
In polar coordinates, okay?
No, 'cause you're
The
looking
first
at
is
the
the angle, right? That's the direction you're supposed to head in.